Hey everybody, welcome back to Algebra 2. Today we're going to be talking about how to solve linear quadratic systems. So a linear quadratic system is where you're going to see a set of equations, usually gathered by a set of braces. They're not always there, but a lot of times they are. And you'll have a linear equation and a quadratic equation. So linear meaning if we were to graph it, you would see a line. Quadratic meaning if you were to graph it, we would see a parabola. And then you can spot the differences in the two equations. Linear will have the equations that are linear equations will be written like y equals 3x plus 2, where the x's have an exponent of 1. And I'm going to write this in reverse color. It's going to bother a lot of people. Quadratic, if you write a quadratic equation, 3x squared plus 4x plus 7, I'll know that it's a quadratic equation because the x has a squared, an exponent of 2 on it. So quadratic meaning x squared, linear meaning x. So if I look at this problem in example 1, I can go ahead and tell that the top one is quadratic. It's a quadratic function because it has an x squared in it. And the second equation is linear because it just has an x to the first power. So we'll be looking at systems that have a quadratic function and a linear function. So we're going to start off by determining the number of real solutions. So it's not asking me what the solutions are, it's just wanting to know how many solutions there are. So one way that you can solve a linear quadratic equation is to solve by graphing. So when you solve by graphing, the first thing you're going to do is you're going to graph both equations. And then you're going to find the points of intersection. And the points of intersection are the solutions. So if you'll notice, my system has x's and y's, so my solutions will be an x and a y. So we're going to solve this. We're going to graph it on Desmos. So let me pull Desmos over here. So I've pulled Desmos over here. I'm going to graph both equations, y equals 3x squared and y equals 3x minus 2. And I'm looking at the graph, clicking around, not seeing that the points intersect or the graphs intersect. It doesn't look like the graphs intersect at all. But just to be sure, I'll zoom out and zoom out and zoom out and zoom out. And even though from really far out, it looks like they might intersect, always zoom in to see if they actually do. And it looks like, nope, they do not intersect. So the number of real solutions to this system would be 0. So these graphs do not, these graphs do not intersect. So we have 0 solutions or no solutions. So there's actually 3 things that could happen whenever we are solving a linear quadratic system. So if I have a parabola or a quadratic function and a line never intersects, just like what we saw in the first example, we would say that would be no solutions. No solutions, no intersections. The other thing that could happen, if I were to have a parabola again, and the line were to actually cross through it 2 times, that would be 2 solutions because there's a point here and a point there. So I could have 2 solutions. And I would have coordinates for each point, an x and a y for each point. So I would have an x1 and a y1 solution, and then I would have a second x and a second y. There's one more possibility that could happen, and that would be that if I had a parabola and the line only hit the parabola at the vertex. It only hit it one time. That would be me having one solution. And you would just have an x and a y as your answer. So that's how you would solve it graphically. We can also solve linear quadratic systems using substitution through algebra. So example 2 has us do that. So we're going to solve using substitution. And substitution means that we're going to substitute one equation into the other. So to solve by substitution, I'm going to substitute one equation into the other. So let me color coordinate these. Let me make my top one be purple. So I'm going to highlight the top one purple. And I'm going to highlight the bottom one blue. Okay, so I'm going to solve my top equation is already solved for y. So I'm going to take what y is the same as, because the top equation says y is the same as 2x squared minus 6x minus 8. So then I'm just going to replace the y in the second equation with 2x squared minus 6x minus 8. So that's going to allow me to rewrite the second equation as 2x minus, and instead of y, I'm going to substitute in 2x squared minus 6x minus 8, because the top equation says that y is the same as 2x squared minus 6x minus 8. All right, so then I now have an equation. So let's combine like terms and see what's in front of us. This negative does need to distribute. So I'll have 2x minus 2x squared plus 6x plus 8 equals 16. And then when we combine like terms and put it all in standard form, or at least gather all the terms on the left in standard form, I have negative 2x squared. 2x plus 6x is plus 8x plus 8 equals 16. And then I have an option on how I want to solve. So after you substitute one equation in the other, then your second thing that you'll need to do is you'll need to solve by any method you want. We've done a bunch of methods at this point. You can factor. If you only have an x squared but not an x, you could do square roots, but that option's out because we have an x squared and an x. Factoring's taking square roots. We can do completing the square. This is just a giant I. Completing the square. Or we could do quadratic formula. Any of those methods are great as long as they work. And remember, the only methods that work all the time are completing the square and quadratic formula, but they might take longer. So I always tend to start with factoring first. I'm going to try factoring. So that means I need to set this equation equal to 0. I'll subtract 16 on both sides from the like terms. Negative 2x squared plus 8x. 8 minus 16 is negative 8 equals 0. There is a greatest common factor of negative 2, so I'll factor out negative 2. That leaves me with x squared minus 4x plus 4 equals 0. And if this factors, I don't need the parentheses there. I need it around the 4. Okay, so now let's see if this factors. Bring down the equals 0. X times x will give me x squared. 2 times 2 multiply to give me negative 2 times negative 2 multiply to give me positive 4. Negative 2x and negative 2x will add to be negative 4x. So it is factored. Now I can solve. I'll set each part equal to 0. Negative 2 equals 0. X minus 2 equals 0. This is the zero product property, by the way. Okay, negative 2 is not equal to 0. Add 2 to both sides, I get that x equals 2. Add 2 to both sides, looks like I get x equals 2. Now I do have two solutions, but my two solutions are actually the same. So since these are the same, then that means I really only have one solution, which means I have a scenario where I have a parabola with the lines only hitting it one time, right there. Okay, so I have one solution, so I've solved it. So when you solve, that's going to let you find the x. My solutions have an x and a y. So my next step after, so step 1, substitute, step 2, solve for x, step 3, you're going to need to find the y. And I find my y by taking my solution x and substituting it into either one of these equations. So I'll substitute mine into the top. I know that y equals 2x squared minus 6x minus 8, but I figured out that x was 8. So y equals 2 times 2 squared minus 6 times 2 minus 8, which is 2 times 4 is 8 minus 12 minus 8. So 8 minus 12 minus 8 is negative 12. Yes. So I got that x equals 2, y equals negative 12. So my solution is the point 2 comma negative 12. One solution, and it's 2, negative 12. If you were to get two different numbers for x, you would do this process twice. So I would go through and substitute in 2, find a y value, and then I would go through and substitute in my other x and find the other y value. All right, moving on. Let's do a word problem. Example 3 says revenue for the high school band concert is given by the function y equals negative 30x squared plus 250x, where x is the ticket price. They're telling me what x is, so I'm going to highlight it. X is the ticket price in dollars. The cost of the concert is given by the function y equals 490 minus 30x. At what price? So they're saying at what price? That means that they want to know what is x. What is x? Will the band make enough revenue to cover their costs? So I need to figure out what represents cost. Well, it says the cost of the concert is given by the function. So that means y is the cost. Now they give me this word revenue. Revenue is the amount of money taken in. So think of this as being the money made. So they want to know at what ticket price, what x value, will the band make enough revenue to cover how much it costs. So they want to know what is x in order to make the revenue equal the cost. So, because you don't want to throw a concert where you lose money, you want it to at least cover what it would cost to put on. So they gave me a formula for revenue, y equals negative 30x plus 250x, and then they gave me a formula for the cost, and I want to know when they're equal. So I'm going to set these equations equal to each other. Negative 30x squared plus 250x equals 490 minus 30x. So I'm going to solve this equation. Let's get it in standard form and see what we have. So I'm going to add 30x to both sides on the like terms. And then I'm going to subtract 490 on both sides. So then I'll have negative 30x squared plus 280x minus 490 equals 0. I have a quadratic equation. My methods for solving quadratic equations are listed above. I can either factor, square roots, complete the square, or quadratic formula. I like to try to factor first because it usually tends to be the quickest way. So let's try to factor. Is there a greatest common factor? Yes, I can factor out a negative 10 from all three terms. So if I factor out negative 10, I'll have x squared minus 28x. Minus 28x plus 49. And actually that's 3x squared. Negative 30 divided by negative 10 is 3x squared. Minus 28x plus 49 equals 0. So now let's try to factor. Bring down that 10. The only way to multiply and get 3x squared is by taking a 3x times an x. To get 49, I'd probably need a 7 and a 7, and I want to make sure that when I combine my like terms, 7x and 21x, 3 times 7 would be 21x, they combine to be negative 28, and they will if they're both negative. So I'll do 3x minus 7 and x minus 7. So then I'm going to erase this part. Okay, so now let's apply the zero product property. Set each factor equal to 0. Negative 10 equals 0, which that's not true. 3x minus 7 equals 0, and x minus 7 equals 0. So 3x would be 7, and x would be 7/3. X would be, add 7 to both sides, x would be 7. So what x values would cover the revenue cost? Well, I've got two options, 7/3 and 7. And 7/3 dollars, if I change that into a decimal, because we're talking about dollars here, this is approximately $2.33. So ticket prices are X. So ticket prices of either $2.33 or $7 will make enough to cover the cost. And if you're thinking, that sounds weird, they could charge $2.33 and make enough to cover the cost, or they could charge $7 to cover the cost. So I think it would help if we would look at this graphically as well to see what's happening. So let's slide our work over here. There we go. Let's graph this on Desmos. So I'm going to graph the two functions. The revenue function is y equals negative 30x squared plus 250x. And the cost function is y equals 490 minus 30x. I may need to resize. Where is, I know I have a parabola somewhere. There we go. It looks like it's a really skinny parabola, so I'm going to zoom in just a little bit more, and then I'm going to adjust my x settings. So I'm going to say x-axis really only needs to go from about negative 25 to about 25. That will probably give me a better picture. Here we go. Okay. So we said, let's pull up the functions again. The revenue is the green function, and the cost is the purple function. So if you notice, the more tickets they sell, the cost goes down of putting on the production. But revenue, so the more tickets they sell, for a while, the revenue increases. But then if they sell too many, then the revenue is going to start to decrease. And that does happen a lot in production and just in general. So they would actually make enough to cover the cost in between. Well, they would cover the cost if they charged $2.33 or $7, but they would make money whenever the parabola would be higher. So they would make money if the cost would be more than $2.33, but less than $7. Because if you start charging more than $7, then fewer people are probably going to come, and then you won't make as much money. So it's kind of like you're asking, how much can we charge before people start saying, that's too much, I'm not going anymore.